Hey guys, welcome back. In the first two parts of this sequence on how to factor quadratic expressions, we have been discussing quadratic expressions that have a leading coefficient equal to 1. Now, for this part 3, we're going to begin talking about expressions that have leading coefficient different than 1. Let's begin with our first example. 3x squared plus 12x plus 5. So notice that the main difference here is that our leading coefficient is no longer 1, but it's a 3. When you have these cases, you need to start considering not only the factors of your constant term 5, but you also need to consider the factors of 3. So if you think about them, as their prime numbers, they only have one pair. For the case of 3, it's 3 and 1, and for the case of 5, it's 5 and 1. What does this mean? In the case of 3, we have an expression or a term that is 3x squared. So as the only factors are 3 and 1, so this guy can only be split down into 3x and x. And these are going to be the first terms of our two parentheses. So here we go, 3x and x, just as usual. Now, on the other hand, you have 5 and 1, and you know that the factors of the constant term are always the numbers that go in the middle, in the blank spaces that you have left. We used to have a test that you just added them and you obtain the term in the middle. But if you add 5 and 1, it's 6, and you want to 16. That happens only when the leading coefficient is 1. When the leading coefficient is different than 1, like in this case, we need to do something else. So pretty much we're going to begin trying. So there's two possibilities. The first one, if I write the 5 first and the 1 second. And the second one, if I do a second copy of this parenthesis, but writing the 1 first and the 5 second. Now, we know how to expand this parenthesis. It is easy to remember that we want to multiply these terms first. 3x and x will always give us a 3x squared, and that happens in both parentheses because the multiplications are pretty much the same. What is going to be changing over here is who are going to be the terms that come in the middle. That happens when you multiply the outer terms. In this case, you have 3x plus 1, which gives you 3x, and 5 times x, which gives you 5x. Now, if you check out the second parenthesis and perform the same operations, you obtain 15x plus x. Now, remember that in this type of expressions, you can add similar terms. That would mean that in the first case, you obtain 3x squared plus 8x plus 5. While in the second one, you obtain 3x squared plus 16x plus 5. Notice that these guys were the ones that gave you 16x as your term in the middle. That is what you're looking for. That means that this guy is our solution. The factoring for this parenthesis is 3x plus 1 times x plus 5. Let's repeat the process to check it out again. Imagine you have now 5x squared plus 11x plus 2. Once again, you begin checking out the factors of those two numbers, 5 and 2. Again, we have prime numbers, so you just don't need to worry a lot. Remember that 5 is linked with the 5x squared, which means that this guy gets split into 5x and x, and those are going to be the first term of your two parentheses, 5x and x. Once again, we have one pair of factors for the constant term, 2 and 1, so I need to try them out. What happens if I write the 2 first? What happens if I write the 1 first? Now, just as we saw in the previous example, you know that the multiplication of 5x and x is going to give you 5x squared, so you don't have to worry a lot about that. And you know that 2 and 1 is going to give you 2, just as 1 times 2 gives you 2. So you don't have to worry about the first and the third term. We are only going to be checking what happens with the middle term. So remember, the middle term comes out from the addition of the multiplications of the outer and the inner terms. So 5x times 1 gives you 5x. 2 times x gives you 2x. When you add them, you obtain 7x. 7x is different from the 11x that we're looking for, so this guy is not what we're looking for. Now, if you check out our second possibility, 5x plus 1 times x plus 2, you know that the term in the middle is produced out of the same pair of multiplications. 5x times 2 gives you 10x, x times 1 gives you x, and when you add them, you obtain 11x. Notice that this 11x is the one you're looking for, so you just found your solution. The factored form for our 5x squared plus 11x plus 2 quadratic expression is 5x plus 1 times x plus 2. Thanks for watching, guys. Factoring quadratic expressions part 4 is coming up next, and it will include an easier way to write down all of these possibilities that we discussed in this video.